So how do I solve this what? How do you solve? You need, so here this k goes from 0, 1, 2 etc. So you want n iteration, correct? K goes from 0, 1 to n. K goes from 0, 1 to n, correct? So if k is 0, I must have this. That means I must know my k1, x1 0, x2 0, x3 0. Correct? Yes, which is nothing but if you want write compact model x0. I must know this, correct? This one I must know, correct? The initial guess I must know, then I can perform my, I can find the x1. Understand? So put here k equal to 0, this x2, x3, you know everything, correct? You can compute the, is clear? Or no? Sorry? Yes, please. This equation there? That's the thing. See, I want to find x1 from here. You put this side, b1 minus a1 to x2, a13 x3, correct? Yes? Okay. See, I can rewrite this as x1 is equal to 1 by a11 b1 minus a12 x2 a13 x3, correct? I can write this. So now I want to iterate on this xk plus 1 form, correct? So this is k plus 1, this has to be k because xk plus 1 is g of xk like this, correct? I will write the unknown terms in terms of known. You understand? I will write my unknown, correct, in terms of known. For example, suppose take k equal to 0 here, correct? Suppose take k equal to 0, what happens? Take k is equal to 0, I will get my x1 1, correct? What is the answer for this? 1 by a11 b1 minus a12 x naught, correct? x2 naught, correct? Minus a13 x3 naught, correct? Yes? But as I told you, I know this in advance because initial guess I must have, correct? X naught. If you know your x naught, suppose this is 0, 0, 0, correct? Suppose this is my 0, 0, 0, correct? Suppose. Then I can solve this for x1. Put here 0, put here 0, you get the x1, correct? Similarly, I can find my x2 1 and x3 1. It is clear? It is clear to everyone or not? Now if you want to examples, so you have to give some value to a11, correct? Let's say 5, 2, 3, something, correct? Then nothing changed, correct? You have to give some value, let's say 5, 2, 3 and solve this, correct? It is clear? You have to give some particular value of a11, that's the solution. So similarly, let me write these steps. I can write this x21 as, help me, a22 b2 minus a21 x1, correct? Okay. Yes. And then minus a 23 x3 0, correct? Yes, I know my x2 0, I know my x3 0, I know my x1 0, so I can compute x2 1, correct? Similarly, I go for x3 1. What is 1 by a33? We are doing this blindly, but I'll tell you logic after that. b3 minus a31, correct? x1 0 minus a32 x2, correct? It is clear? It is clear to everyone? So I know my x1, x2, x0, so I can compute my x1, 1, x2, 1, etc. Correct? Yes? It is clear? This is what we have at a fixed point. Exactly same we are doing. Using x naught, I will find x1. Using x1, I will find x2 and keep on doing. Correct? It is clear this step you have or not, please? Okay. Similarly, if you want x1, 2, you write here 1, 1, 1, 1. Correct? Or I will write. It's clear, no? So next step would be what? You write in your notebook. It will be become 2, 2, 2. Correct? Yes. And this becomes 1, 1, which you already computed. Correct? Yes. Yes. Now I can compute my this. That means I can go for second iteration. Correct? I can go for second. So only trouble again, I must now have my x1. Correct? Now next question is, okay, our favorite question is, so xk means what is a vector? So x my vector, correct, please? Since we wrote a to b form, correct? In this form, correct? X means what? This is a vector. x1, x2, x3, correct? So if you say xk means what? x1k, x2k, x3k, correct? What will this converge to x? Which is my solution. Which is my solution. I can make anything whatever I feel, but finally I have to answer whether this will converge or correct. Okay, it's clear? Now let us relate what simple thing we have done with this, because our idea is to write x into tx plus c. That means you have to decompose a is m minus n, with restriction that m has to be a known singular matrix. That is determinant of m is correct. Question is, in this case, so this is right. Understand, this is my a x equal to tx plus c form. Correct? Question is, okay, in this case, what is your m and what is your n? In this case. Okay? You understand my question? Tell me. So you can check. Look at, m is nothing but here d. D is what? The diagonal matrix. D is nothing but the diagonal matrix. That is nothing but, you know, correct? You have here A11, A22, A33. How? Because you can easily check. You are dividing by this, no? A11, A1. This is what M inverse, correct? Yes? What is M here? I will tell you, this is L plus U. This is L in lower triangular matrix. I will tell you and I will come back to this. But you don't have to write it. This is L is what? Lower triangular matrix. U is upper triangular matrix. But next question would be which will answer whether, suppose you have a matrix n by n matrix, correct? Can we always write A as L into U, means lower triangular and upper triangular. Okay? But theoretically you can check, this is my M, this is my N. Okay? So we proceed very naturally, correct? If you don't want to remember it, don't remember it. I don't care. I don't want it. Okay? You don't remember it. This method, which you might have taught in 5th class, given by the Jacobi. This is what your Jacobi method is. That's all. This is what your Jacobi method is. So Jacobi method is this. So this is the method, but the underlying principle is, in Jacobi method, see, you have to write Ax equal to x tx plus c. In every case this t will change. So for Jacobi method, my t is m, this one, m inverse n, correct? Yes, m inverse n. What is m here? D, and n is L plus u. So that's right. For Jacobi method, my m is D and n is L plus. This is just some theoretical things. If you don't want it, it's okay. But that's what the Jacobi scheme is. It's very natural, correct? We have not done anything new. It's a very natural we proceed and we get the Jacobi However, we left one question that what is the guarantee that this will converge? And again the question is whether this will converge for any x naught. Correct? Because understand, like the Newton method, the only problem is to have a initial point. Otherwise it may not. Whether we have to face same problem here or not, that we have to answer. Correct? It is clear? Okay. Now, so can we do some examples? Example is what? To take some particular value and iterate on this, correct? Keep on iterate. That we have done the fixed point. Correct? So there is nothing changed. Idea is okay. So this is what the Jacobi method. Again we have now question one that conversion. Now question is whether there would be a different choice of m and n. That means whether there will be different t. Correct? Can we have different t also? Because there will be many choices, right? It depends on me. It depends on me. Correct? So let us see. Is this clear to everyone so far? This Jacobi method? If not, please tell me. How many clear? No one. It's clear. Raise your hand like this. Come on. Last row is not clear. No? Or half clear. Then the rest will be clear once you work out some examples, correct? Okay. Same thing, idea is. See, you have to, as I told you, you have to put some effort to understand it. You have to put some effort. Like, people play a joke, correct? Will say, nothing is impossible, correct? But one fellow said, I am doing nothing from last several years. That is possible. I am doing nothing last several years. That is possible. Correct? So it's up to you how to interpret things, correct? So to understand this, you must have to put little effort. If you are sitting idle, even if you watch a movie, correct? Sometimes you have to use your brain. What happened next? Use your brain or not? So here little is required, correct? Little. If you simply sit idle in a movie also, you won't enjoy a movie also, correct? Will you enjoy or not? You will enjoy. Without putting your brain. Yeah? You have to put your brain, correct? What happened next, correct? Then only you will enjoy. If you simply sitting idle, where are you? What the fun, correct? You have to put little up, and use your common sense. That's all. Nothing more than I told you. We need that. Here, what we have used, your common sense. And this is what Jacobi did. This is what Jacobi did. Don't say anything. Correct? No, nothing new. Just natural. Now, what next could be done? Here, the problem is, look at. So, let me start here. To compute x1k plus 1, I am using x2k, x3k. Done, correct? But now, this you have computed, correct? Done. Yes, in next step, x2k plus 1, I am still using this x1k itself, correct? Why? I have already computed it, x1k plus 1, correct? So, what wrong if I write here k plus 1, correct? So, what would happen if I write here k plus 1? Yes, because I have computed it. I know this value. I know this value, correct? Similarly here, I can put here x1 too because I have computed. Similarly, I have x2k plus 1. I can write here k plus 1 and here also k plus 1. Correct? This is a simple idea, correct? This is the simplest. Because I want to make use of what I have. And this is nothing but your Gauss-Seidel method. See, this is what your Gauss-Seidel method is. Nothing else. Gauss-Seidel method. Nothing new, correct? This is what your Gauss-Seidel method. The much more common sense. Whatever I have, I must use it. Correct? Whatever I have, I must use it. That's the only idea we have. Correct? It is clear? No. Clear, no? So if you write the for k equal to 0 for Gauss-Seidel method, what happened? Tell me. Let us write. Okay. So what should I write? Tell me clearly, and immediately we can. So 4k is equal to 0. I have this correct already, x naught. So 4k is equal to 0. I must write my x11, x21, x31. What it is? Right, 1 by a11, b1 minus a12, x2, 0. Very good, correct. Minus a13, x3, 0. Correct. Write down x2, a22. You may ask me several questions. You are not asking how do I know my a1 is non-zero, correct? That you have to ask me, but you are not asking. You should ask. I will tell you later. b2, yes, come on. b2 minus a21, x1, correct? Because I know it. In Jacobi method it was x1 0, correct? That's the one. Minus a23, x3, 0, not 1. Because I don't know this, correct? You understand? I do not know this. x31 will be what? a33, b3 minus a31. What is that? x2, x1, correct? x1, 1, correct? Minus a32, x31, correct? So if you want, you can write bracket, otherwise this will. You understand it, correct? Very good. See, if I do mistakes, oh, why you are doing mistakes, correct? Okay. So this what you Jacobi method is correct. Now question is, what is the corresponding change here in m minus n, correct? Because everything, this idea is based on this t, is based on this t, correct? This idea is based on your t. Like here you have a different h. In fixed point you have a different h. So for Newton method they have fixed our h and it works, correct? It works. Same idea we have to see. What is my m and n for Gauss settlement. My m is, I think it is d minus l. That you can verify, and n is u. That's all. That's what. Because it doesn't depend. See, people have not thought like I am explaining you, right? They thought like this. What are the possible choice of m and n? And that was the answer. Another way would be, now look at the other, which I will not tell because no, it's not part of syllabus. Is it possible to have here x2 1 itself? Here I have 0, right? Everywhere. I must make use of x2 1, x3 1 also. That is what your successive over relaxation method is. But that will not touch. Okay. Okay. So we have two methods: Jacobi method and Jacobi method and Gauss Seidel method, for which we have different m and n. Question is whether they will converge or no. If they don't converge, useless, correct? I can also give choice of m and n, correct? I can also give different choice of m and n. If then converge, this is useless. Agree or no? If then converge, this is useless. The question is whether this will converge or not. So that means actually this is a big problem started like this. A equal to b, you want to solve this a, you know, correct? Then you are trying to convert x is equal to tx plus c, correct? For different method there will be different t because the t depends on m and n, correct? Very good. T is nothing but your m inverse n. Okay. Correct? These are matrices. These are question. Natural question would be what condition we should impose on T, because like x equal to g of x you have, correct? X equal to g of x. You know what are the conditions are imposed on G so that it has a unique fixed point. Correct? Same questions would be asked here. What are the conditions should be imposed on T so that it has a unique fixed point. But later the many theorems have been proved, many theorems worked out. Then finally we have a condition on A itself. Finally we have a condition on A itself. This is the intelligent story that first we have a condition on T only, correct? Many conditions put on T only. But finally we can have a condition on A itself, because A is given to you as it is, correct? No need to look for what is my M, what is my N. No, I will have a condition on A only. The condition is, and that's also the remarkable theorem. See, you must be happy. If A is SDD, correct? If A is SDD, what is that? It's P. Strictly, diagonally dominant matrix, then Jacobi method, Jacobi and Gauss-Seidel method. So schemes, iterative schemes, converse for any x naught. That's all. And your problem is solved. For any x naught, this will converge, and our problem is completely solved. But I made this statement in one line, but it took several years to come out. Okay. So you know your A, correct? You know your scheme like this. No, remember your what is your M, what is your N, correct? You know your A, you know your scheme, that's all, finished. But it should be SDD. If it is not SDD, you are allowed to change. Okay. After this, I will ask you these two questions. One is, if determinant of A is non-zero, suppose, that means what? It's a inverted matrix. Does this true A is SDD? Okay? Okay, this is one question. Second question is, if A is SDD, does it imply that determinant of A is non-zero? These two questions we have to answer and see. Okay? Can you have to think about it? That's all. If A is SDD, you are true. Because A is SDD, I told you it has a unique solution. Correct? And everything is done. So we stop here for 10 minutes. It is clear? Yes. That's the idea.